Hello viewers, welcome to another edition of Brain Maths. In this video, we want to look at the trigonometric ratios of special angles. But before we start talking about special angles, we need to look at the triangle as a whole. If you are given a right triangle, the triangle that has 90 degrees, how do we know that a triangle is having an angle 90 degree? This is noted by the meeting of a vertical line and a horizontal line. When you have a vertical line meeting up a horizontal line at that point where the two of them are meeting, that is where we call our right angle. The line that joins both the vertical and horizontal line together is what we call the hypotenuse. The hypotenuse is also the longest side in a right triangle. Not only that, the hypotenuse usually starts what we refer to as Pythagoras theorem. Whenever we want to solve problem on a right angle, that is when you're looking for the length of one side of a right triangle, that is a right isosceles triangle, then we use what we call Pythagoras theorem. But before we come back to Pythagoras theorem, let us try to name the sides of this triangle. Having noted our hypotenuse, the two sides that we are having left, what will determine their name is based on where the angle we are given is facing. Assuming our angle is here, any side facing the given angle is known as the opposite side, the side that is opposite the given angle, while the side that is between the right angle and the given angle is called the adjacent. Look at this triangle. For instance, if our angle is here, the side facing this angle is this side. So this place will be named opposite. There is no doubt this is our hypotenuse. The hypotenuse is also the side facing the right angle. Hypotenuse. While this side that is in between these two angles is regarded as the adjacent. So, irrespective of how the triangle is drawn, if your triangle is drawn like this, if this is the way our triangle is drawn, this is our vertical line and this is our horizontal line. So, the side facing the two of them is the hypotenuse. So, this is our hypotenuse. And if this is the angle that is given to us, there is no doubt that this side is the opposite, while the upper part here will represent the adjacent. And if your triangle is given in this format, anyhow it is given, just make sure that you note where the vertical and horizontal line meets. That will determine where your hypotenuse is. And if this is the angle, this side will be the opposite, while this side will be the adjacent. And if the hypotenuse, if the right angle is not shown in the triangle that is given to you, assuming we are given this type of triangle and they are not showing us the right angle, they are not giving us, this place is not shown. Let's say we are only seeing the angle that is given to us. So you can do this by yourself by locating where the right the vertical and the horizontal lines are meeting to determine your hypotenuse. So this will be our opposite, while this side will be the adjacent. Having noted the name of the sides of a right triangle, the next thing we want to look at is the special angles. So let's start with angle 45. In this right isosceles triangle, this side and this side are equal. So if this side is 1, this side will also be 1. This place is given as 90 degrees, and the remaining two sides will be 45 degrees each. So this is to tell you that 45 plus 45 is 90, and 90 plus 90 is equal to 180 degrees, which is the total angle we have in any triangle. Now, having noted this, we need to note what the value of our hypotenuse is. Assuming this is our triangle ABC, so we want to determine the value of AB. So from Pythagoras theorem, Pythagoras theorem states that the square of hypotenuse, which is AB, is equal to the sum of the squares of the two other sides, CB plus AC square. So our AB is unknown, CB is 1 squared plus another 1 squared for AC. AB squared will be equals to 1 squared plus 1 squared. That is 1 plus 1, which is 2. And we are looking for the value of AB. So to get the value of AB, we introduce square roots to both sides to eliminate the square on this side. And AB will be root 2. So the value of our AB here is root 2. So therefore, for us to determine the special angles, angle 45 for this, our sine 45, which is opposite over hypotenuse, will be equal to the opposite here could be any of these two. Since the two of them are 45, so if we are facing this place, we are having 1, and if we are facing this side, we are also having 1. So any one of them could represent opposite. So opposite is 1, and our hypotenuse is root 2. We are generating all this because we'll be linking them later to our sod. Cos 45, therefore, cos 45 degree equals to adjacent over hypotenuse. Our adjacent could be this, may also be this, bearing in mind that any side between both the right angle and a given angle is the adjacent. So that is also 1 over root 2, while our tan 45 will be opposite over adjacent, and that is equal to 1 over 1, which is equal to 1. So in our special angles for angle 45 degree, both sine 45 and cos 45 are 1 over root 2. It is only tan 45 that is equal to 1 in angle 45 degrees. Now let's look at angles 30 degree and 60 degree. So to show this, we are going to take an equilateral triangle. An equilateral triangle is an angle that has all its sides equal and all its angles equal. And if this is B, C, this side, this angle will be given as 60 degrees, 60 degrees, 60 degrees. This side is 2 centimeter or 2 units. Let's just use 2 units. If all the sides are equal, as the definition states, then if we divide this into 2 equal parts, then our 60 degree from here will be reduced to 30 degrees each on each side, and our 2 units here will also be reduced to 1 on each side. But if we look at this triangle very well, that is divided in the middle, if we take 1/2 of the triangle now, this side is 2, this side is 1, we have A, let's name this side D, we have C, we have D. We need the value of this side. This side is 30 degrees and this side is 60 degrees. So we need to determine the value of this side. From what we are looking at on the board, this represents another right triangle. So by Pythagoras theorem again, the square of the hypotenuse, which is this, is equal to sum of the squares of the two other sides. Sum of the squares CD squared plus AC squared, and this is equal to our CD is 1 squared plus our AC is, okay, our AC is the hypotenuse, our AD rather, CD and AD. So our AD is the unknown, so we repeat it as AD squared. So this one is going to be 4. 1 squared is 1. So when you collect like times, you have 4 minus 1 equals AD squared. So 4 minus 1 is 3, and our AD squared is left. So what we need to do here is to find the square root of both sides to determine the value of our AD. So our AD now will be equals to root 3. So this side is root 3. Now we want to determine the angles, the special angles 30 and 60. So let's start with 30 degree. For sine 30 degree now, this side is now root 3. For sine 30 degree, this is sine 30 degree. Sine 30 says opposite over hypotenuse. This is our opposite, 1. Our hypotenuse is 2. So sine 30 is 1 over 2. Then sine cos 30 is adjacent over hypotenuse. Our adjacent is root 3. Our hypotenuse is 2. So that is root 3 over 2. And our tan 30 degree is opposite over adjacent. Our opposite is 1. And our adjacent is root 3. So this is 1 over root 3. Then going to 60 degrees. Our sine 60 degree is equal to, this is 60 degree now, so we'll be using everything that relates to this one. So opposite, this is opposite of 60, opposite over hypotenuse, which is equal to root 3, and our hypotenuse is 2. Then cos 60 degrees is adjacent over hypotenuse. Our adjacent for 60 is 1, this place, 1 over 2, and our tan 60, which is opposite over adjacent, this is the opposite over adjacent, root 3, and adjacent is 1, which is root 3. So bearing all these in mind, for sine 30 and cos 30, the two of them are 1 over 2, and cos 30 and sine 60, they are also root 3 over 2. Tan 30 is 1 over root 3, while tan 60 is root 3 itself.